You can share if you want to present from your laptop. You can share your request to share your screen.
You can share the screen. Yeah. So if you come to this, I think you need to log into the client.
Okay, I'm getting started. So
Yeah.
all right.
Full client mode and then.
Okay, it's 2:30. Welcome everyone to TSVWG. Oh man, what's happening here? How come I can't get to the? There we go. Okay. There's a lot of lag here.
Yeah, just having some error.
Oh, this is in the reverse order. Is it? What is happening? It is in reverse. Nope. There we go. Okay, in spite of the enormous lag on Meet Echo, we're going to try that again. Welcome to TSVWG. This is the new IETF note. Well, it's only the third session of the week, so in case this is new to you, the IESG has revised the note well statement. It is totally reworded. Please have a look at it. There's a QR code there that enables you to peruse it in great detail. If you've not already and you're present in the room, please use the Meetico client to scan the QR code to start the Meetico client so that your presence is recorded here. In general, you should leave your audio and video off, whether or not you are in the room. If you are in the room, please mute your audio so we don't have any sort of feedback effects. Mute your speaker, rather, not your microphone and your speaker, but especially your speaker. And as always, we're going to use the queue. You use the raise of hand tool for to get yourself in the queue. Here's some resources for the meeting here, some logistics regarding Meetico, the agenda, and any other technical assistance you might require. We needed a note taker for today. We failed in getting a pre-agenda taker. As always, we don't need a verbatim of what happens at the meeting. There's a recording for that. We just want the key decisions and some of the main points to come up in discussion. So a concise summary is better than a detailed one. Is anyone willing to take notes for the meeting?
Chris.
Thank you.
Thank you, Chris.
Okay, thank you, Chris.
But do you have an backup? So in any case, somebody else wants to volunteer? Okay, yeah. Yeah.
Thank you.
Your name, please. Yeah, so we have two.
Yeah. Thank you to our scribes. TSVWG is a grab bag of subjects from the transport area. And so people are here for different reasons, but every meeting we ask people to come a little bit outside their area of expertise and review some drafts. If everyone just comes here and reads their own stuff, we aren't going to get anywhere. So your willingness to review documents that you're not specifically here to promote or talk about is essential to the function of the working group. So please do so. And thanks to those of you who have been reading drafts and sending comments to authors. That's how this group runs. Here's today's agenda. There have been several changes over the past few days as we've had some late requests and slides have come in and the length of presentations has been clear. We don't have quite a full agenda. I've asked the presenters not to go over their allotted time, but if we do find that a discussion is proceeding well and covering a lot of good ground, we're probably going to let it run. But we don't want the slides to go on forever. Would anyone like to bash this agenda?
Michael Tuxen, just a note, the last presentation is not about the key management, but about the DTLS chunk. The name of the draft is wrong.
Okay.
We can fix it.
All right. Thank you, Michael. So what was said at the mic was that that is actually the wrong link for the draft. DTLS chunk key management is not the same thing as DTLS chunk. It is, in fact, about the DTLS chunk draft. All right. As always, we're going to give a brief overview of what we've accomplished since IETF 124. 2 drafts have gone to RFC. Congratulations to the authors of those drafts. We've passed 3. There are 3 drafts currently at the RFC editor. You can see what they are there. And there's one at the IESG. There's some comments from AD review that need to be resolved. And eventually, user experiment draft should proceed to the RFC editor as soon as the author takes care of the problems.
Yeah, I mean, we need to have the Shepherd to write the Shepherd write-up.
Oh, pardon me. And the Shepherd write-up is still due on that.
Yeah. And Mohit is the Shepherd, so.
We've concluded last call on UDP ECN. There's, I think, one outstanding issue in the GitHub. Once the author, whoever that is, resolves it, we should be passing that on to our area director. David.
Shepherd write-up is in fine shape for the experimental ports draft. There are, however, some serious issues raised as IESG discusses that are going to need some working through. Gory's going to have his hands full with this one, unfortunately.
Thank you for that clarification, David.
Yeah.
I withdraw the comment about the Shepherd write-up. I just talked about this. We need to review documents as a group. There are a lot of people here. If just a fraction of you actually do the work, that will help us move forward. And there's one coming up. L4 SOPs is probably coming up soonish, so it's a good time to read that draft. We wanted to call your attention to a few drafts and other working groups that are related to the expertise in this room. If you're an RSVP enthusiast, there are 2 drafts and Ts that may interest you. Please have a look.
So I can add that, like, there was a request to see like whether the work should be done in TSVWG or TS, and I think we talked with our AD, and we decided to actually have it in the TS working group because they have the better understanding, like the use case they're going through, and obviously they're using RSVP. Will be okay. Can you hear me now? Right. Yes. Okay. So the idea is like the work will go on TS working group, and then when it comes to working on blast call or finalizing the draft, then we'll be in the CC to have a look at it.
David, are you still in the queue?
No.
We've recently revised our milestones because they were badly out of date. Here are the new ones. If you have any comments on it, please email the chairs.
Yeah, I mean, this is just like for your information, there was like an LS send we had, I said for information only, that there has been working going on in broadband networks on L4s. So we know about it. We acknowledge that one. And I think another statement we are preparing, I think Magnus and Michael will talk about it, that we have make some decision about TSVWG, TLS and SCTP DTLS. So that we'll be sending soon, perhaps.
Okay, first up on our agenda is Cohen, talking about L4S.
Request to screen share.
Don't understand. Did that work? No. Try it again.
Let's see.
It says yes, but so request screen share.
What am I supposed to press?
No.
That's not what I want.
Okay, it seems.
No,
it
that was
started.
me.
Ah, okay.
Ah, here we go.
Yep.
There we go. Okay. That button is well hidden.
Yes.
So you see the screen?
Nope.
Not yet, I
Not
guess, right? Do you want to share screen? Yes. Okay. I also have this press button. Is it coming up? Ah, sure. I need to select
If this doesn't come through, I can just load this.
entire screen. Okay, I have to share this. It's a bit finding out what to do now. I'm in an infinite loop, and I hope this is working.
It's not. Do you want to try it again? Or do you want to just have, do you want me to just give you the clicker?
I'll try it again.
Okay. We'll give it one more try.
Request screen share. Yes. Entire screen. Share. It says sharing, but it doesn't seem to come
All
through.
right, this is a no-go. All right, I'm going to just load up the slides the old-fashioned way. Whoops.
Okay.
Oh boy, this is very strange.
So let me just share it from me. Yep.
Okay. Hi, everybody.
Maybe.
A quick update on what's happening with L4S and Prague congestion controls.
Here you go.
Thank you. So the contents, so an update on what's happening on the Linux mainlining, some accurate ECN field experience, some, let's say, opportunities for lower layer network improvements that are being driven by L4S. Also opportunities for improving applications using L4S, and then maybe a short discussion on what could be work to be done in TSV or any other working group. First, mainlining of L4S. It is being done very intensively, but it takes, it seems, a lot of time. So a lot of people are wondering what's happening, but we are continuously working on this since last year, so more than a year. It seems to be quite a challenge. We thought there were 44 patches. We did some internal rounds for 2 months and then said, okay, it will be 1, 2, 3, 4, 5 patches. The biggest one was accurate ECN. And then we submitted the first time. Feedback was accurate ECN too big, have to split it in different parts. A lot of going forth and backward, but we are getting there, let's say. After 1 year, we are halfway, I hope beyond that. So dual pi square is mainlined since version 6.17. Accurate ECN, we had to, unfortunately, also take other impacts with that, so virtual I/O drivers and specifications. So a lot of back and forth and puzzling how to rearrange the patches. But so Accurate ECN is split in 3 parts. Some preparation, which was in March this year taken in. It's already available also in the kernel since 6.15, but it's not usable because it's just changes to prepare. The next set of patches, which are also fully accepted in September, and probably are going to be in 6.18, is again not usable, but it's, let's say, the main protocol. And then the exceptions and special cases and all the testers around, that's the last one. And it will also include the activation of Accurate ECN. So that's the one which is, let's say, active. We already did 5 iterations on that. You see these iterations, how many versions we did and how many times. About every 2 weeks there is a review round and we could make progress. Also for the virtual I/O we did already, but there seems to be some even circular dependencies, it seems, so it's quite a lot of discussions and things going on. And then we should be able to finally upstream the TCP proc itself. So that's still depending. You see in the red arrows at the bottom on the others to progress. Some Accurate ECN field experience, because we are mainlining it, but it can already be used from the versions that we provide, and it is already used in the field as well. So yeah, quickly, Murphy, we all know, and Murphy is always right. If it can happen, it will happen. So there are quite some sanity checks, which is good, of course, but if they can have false negatives, it seems they will happen, and often even in the real life tests, we saw them a lot. And besides Murphy, also Stuart warned for this in the mailing list before. So good to have a check on that. So quickly, it's just a check whether the middle boxes clear the ACE field, and if 2 messages are, or if the ACK of the ACK is dropped, or there is a reordering, it fails actually, and it says there is a middle box where there is no middle box doing this. So we remove that check and will remove that from the upstreaming. But if there are any other opinions, of course, be free to discuss about this. Maybe also important is that other implementations like the Apple and a FreeBSD, if they also include those checks, it's maybe recommended to remove those as well. Then also in the Accurate ECN draft or RFC, there is already a shoot that mentions the potential problems, but need field experience. I think we have proven that based on field experience, this is not to be done. Also, the impact of a fallback is important. So when measurement tools like RPM and iPerf, they start these B connections, but they're not aware of potential fallback. So measurement results use, like the RPM tool, a random mix of alpha-res and non-alpha-res classic flows. And they have a kind of a mixed result, which is not representative of the network latency, but clearly depends on how many flows were falling back and not. And it would be useful for apps to get notified or to be able to query what's the alpha-res status of a socket after it has been used even. So thoughts on extending the socket ABI with fallback reasons as well is something we should consider, I think. Then some network improvements I want to talk about. So alpha-res has an opportunity to reduce the latency, but then of course there is the MAC latency. That cannot be removed by AQM or queuing. Yeah, before that, even the dual pi square for Wi-Fi implementation, there was also a big discussion about whether Wi-Fi is good for dual pi square is good for Wi-Fi. So we have released implementation guidelines in the WBA, Wireless Broadband Alliance, which was very open and innovative, driven, let's say, to accept this, because yeah, the other are maybe more driven by chip vendors which want to minimize the impact, but at least it's good to have documentation and some push for implementations to do this. And we also wanted to have stations to be able to have dual pi square on their side, because it's not only the access point that needs to support L4S. So, and what I was saying, it's not only queuing latency, it's also MAC latency, and also there we are pushing a bit to use other EDCA parameters, which works better, even better than WMM and video and access categories. So you don't even have to decide which category you use. It's better that everybody uses a low latency and high throughput configuration. And there are even deterministic MAC systems proposed in Wi-Fi, so they could keep a very low, regular, low latency MAC. But also there is more awareness needed in IEEE that this is important, and not necessarily WMM, which works for 1 or 2 greedy users, and then it also becomes worse than best effort. So there we are working as well to improve latency for Wi-Fi. Then maybe another network improvement. I've been saying a few times that PRAC doesn't need to be delayed to control the rate of PRAC. So why do we even build a queue and do active queue management when we can immediately control the rate? And like in real estate, the 3 L's are location, location, location. You might have heard of that. To achieve the 4 L's in L4S, it's also important to have headroom, 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 the 3 H's. So headroom gives L4S flows the time to adapt, while schedulers block immediately and are actually intended to build queues. So stop delivering the packets, wait a little bit until I'm controlling the rate, really enforce the rate, and the queue is necessary and a scheduler is necessary, but for PRAC congestion controls, it's not needed. And like dual pi square, it is actually some kind of active rate management that you do based on the delay or the queue of another classic flow, but the packets themselves get prioritized and controlled by the marks. So it's also possible to do other policies, including like a static L4S rate budget, what we call static rate management. For fixed networks, it's a very easy way to get kick-started in a network without having to do queue management. And there are also other, let's say, active rate management where we can have an aggregate of a user to control all the L4S flows themselves, to make them weighted to other users or equal weights or different weights even, and even to make them work with weighted round robin schedulers for the queue building or the classic flows. So also where active queue management or active rate management even is hard to do, because you have very high link rates or very aggregated flows with lots of users, or it even doesn't make sense to do active queue management. This static rate management is also very useful. But it also has some consequences. Certain assumptions are broken, so it's not a hard limit anymore in the capacity. So headroom is flexible and can be pushed in a little bit when it will come back. So in certain tools, assume like RPM that they have to hit this wall where there is no wall. It can just drive it in overload. So think about how many flows you want to start to know when a network is full. If you always can get a little bit more, even if you're competing with other flows, you can always steal more from the other flows by having more flows. So this mechanism doesn't work even in those cases. And also, it's not in this slide, but There are proc requirements which are very important if the latency can be low, like the round trip time independence and the minimum window, because also there it can drive in overloads. From an application point of view, the previous was also a little bit application, but so this UDP proc that we have with the time which is left, maybe in ICCRG I will explain a bit more how this proc module can be used in different application parts and can be done in the application itself. So it can be in a stack, and it's an easy way to put it in a quick stack or even in a TCP stack. And you see here that the pacing rate and the window is actually done on a buffer, and the application needs to fill that buffer, keep that buffer full. So it's not optimal to have a queue in there even, and the exact tuning is difficult. So, and also users and measurement tools, they will see that queue even because there is no queuing in the network anymore. So, so it's better to use the proc congestion control module immediately in an application and drive the source and have no queues at all for doing measurements. And even for, there were already some discussions how congestion controls are interacted with video encoders. So I will explain as well that is very possible and very easy to use this. And even to do more complex configurations and mix also L4S for low latency interactive and classic socket, let's say, to do the bulk blob source, which is not necessarily low latency, but it's also beneficial to have a queue in the network. So for some networks, it's good to still use classic, and you get higher throughput, mainly on wireless networks, if you use classic. And yeah, for discussion a bit, I think these are the topics. This accurate ECN errata, I think it's more for TCPM. Maybe a discussion on is this fallback always necessary, or should we be forced to fix the network? And what information can be given to applications via API extensions, and maybe for these new network mechanisms beside dual pi square, is there interest of working on that?
Martin Duke, Google. The ACK-ECN draft, according to Data Tracker, is still in the RC ed queue, so we don't need to do errata. In fact, I think errata is a bad way to do something like changing a normative word. But if the TCPM auths want to just go ahead and make that change, like it's relatively straightforward administratively. You just have to check a bunch of boxes with the RC ed and the ISG, etc.
To do the edit now in the...
Yeah, do the edit before it goes to RFC.
Okay.
I mean, it's much worse once it goes to RFC, so do it now.
Yeah, okay.
And Gori is probably responsible AD. Just CC me in so I know what's going on, and then it'll be easy at the end.
Stuart Cheshire from Apple. Yeah, on that subject of fixing the document before the RFC is published, as long as we're transparent that we're not changing things materially, I support that, but that's not why I came to the microphone. It's not a question. I just want to thank Koen for his years of work on this and all the people who worked on getting the accurate ECN draft through the process for a decade. I've said it before, I think this is some of the most significant work we're doing in the internet in my lifetime. We've focused so much on increasing throughput, and now we're focusing on lower latency that enables a better user experience and enables new applications. So thank you, Koen, for your dedicated work on this. You've spent so much time on it. Thank you.
And thank you for all your support as well.
There was an earlier question. This is Neil Cardwell, Google. There was an earlier question about, should we extend the socket API so that applications can find out if an attempt to use accurate ECN was successful? And I think that makes sense. And I think you can just add a patch for that to the patch series. There's already plenty of prior examples of using TCP info to export that kind of information in the Linux TCP stack. And I don't think we need to block on, IETF standardization or something. We can just export a bit that says what happened, basically.
Okay, so you're saying it's already possible in Linux? to
Yeah,
get-
so there's a TCP info socket option, and it already has a couple bits for finding out whether various attempts to negotiate ECN support or timestamp support, SAC support, that kind of thing, whether those attempts succeeded. Yeah.
Yeah. Is this part of the accurate ECN patch set, or is this already there? Neil, question to you.
Sorry about that. Yeah, it's already in there. Just grab
Okay.
for TCP info. Yeah, TCP_info.
Okay.
Yeah, we can talk offline.
Yeah. Okay. Thanks.
Is this accurate ECN change going to be discussed in TCPM this week?
It's not on the it's not on the agenda.
But I guess we can do this via the mailing list, or
Pardon?
can we do this via the mailing list, or do you want me to?
The agenda is pretty full,
Yeah, that
so
was
I
what
would
I
suggest
also
go to the
understood,
mailing
so-
list, discuss it there.
Okay.
Yeah, I'd just like to amend my comment by pointing out that it's an auth 48, which is literally like the very last step to go to RSC. So like whoever the authors are, like don't push the button until we get this resolved.
Let's talk after this meeting directly.
Yeah. Okay. That's it. Thank you.
Thank you.
Thank you, Colin. Next up is Greg with two topics. First, the interop report, and then he's going to talk about a draft and int area that may be of interest.
Great, thank you. So for those of you who attended the, well, actually, Mr. Harber, for those who might be new to TSV Working Group and the topic of L4S, we've been running a series of interoperability events to bring together the congestion controller implementations, both the sending congestion control as well as the ECN feedback mechanism at the receiver, and networks that implement L4S, and enabling testing and compatibility and interop, as well as fairness and other sorts of performance tests. So plug for the interops we've done in the past, as well as ones that will be coming up in the future. So the intention is to help the industry make progress on getting L4S implemented well and deployed in networks. We've held 8 of them at the IETF meetings. We typically start during the hackathon the weekend before, and then are set up in the shared workspace and run testing usually through the week. So that's true of this IETF as well. In addition to that, Cable Labs runs a series of interop events at our facility as well. Those are free to attend. We have all sorts of network gear that's in the lab ready to run different L4S testing. We have a lot of DOCSIS equipment because we're Cable Labs, but it's not limited to DOCSIS equipment. If other network technology companies want to participate, that's welcome. And over the last few years, we've had quite a few organizations participating, different congestion controllers and receivers and network bottlenecks, and would like to continue to promote the support for L4S. This time at the hackathon, probably the newest news is that the Chrome Canary currently now supports an experimental L4S congestion controller in libWebRTC. So it's using the Scream congestion controller from Ericsson. You have to turn it on via some sort of arcane command line flags. That text should all be on one line. Hit enter and you've got L4S support. During the interop this week or last couple of days, there was
it was discovered that the feedback packets, so the RTCP feedback that are sent from either end, are not marked as ECT1, they're marked as not ECT, even though it's the same 5-tuple that's carrying those. And so a bug was filed to correct that, so that all gets the same low latency treatment. Chrome also supports, or has for some time, the WebRTC implementation has support for sending that congestion feedback using RFC 8888. And there were tests done, additional tests done this past weekend with both the Netflix cloud gaming service as well as the NVIDIA cloud gaming service. And one issue was discovered with NVIDIA in that negotiation at the Flow startup around support for RFC 8888, and a bug was reported for that. Next, Netflix also did some additional testing using their different permutations of their ascending behavior on production cloud gaming nodes. Experimented with multiple simultaneous flows, as well as tweaking some of the encoder configurations and exploring performance there. And then the third piece, there were tests done with the prog congestion control module, in particular the UDP version, looking at the new growth algorithm that Kuhn has added, Kuhn and Chai Yu have added to that code base, and he'll be talking, I guess, more about that at ICCRG. Nice couple of plots. I won't spend time discussing these, but if you want to look at them on the data tracker. One with L4S disabled. This is a GeForce Now gaming stream with a TCP a cubic flow that starts about 3 seconds in. So you can see the latency on the top graph jump up by about 30 milliseconds and oscillate around because of the cubic flow. And then enabling L4S. Similar test case, but very little impact on the latency of the GeForce Now flow. Next opportunity, so at Cable Labs we'll have a opportunity to join an L4S interop early next year, probably Jan, Feb sometime. Haven't set the dates for that yet. And then the next IETF L4S interop event is planned for next summer. So if anyone's interested and wants more information, please reach out. Okay, you can move on to the next one. Let's see anyone queue. So
Yeah. That's what I'm looking for.
all right, so this is a presentation about a draft that is currently being discussed in area. In-area meeting is tomorrow. And this slide deck I'll go through in a lot more detail at the in-area meeting, but there are some implications to transport protocols, so I thought it would be interesting for transport folks to be made aware of this. And if there's interest in having discussion today, it sounds like there's a bit of time on the agenda that could be made available for discussion, but also would invite you to attend the in-area meeting tomorrow. So just to this, and then the first version of this draft, there were 3 of us that came together to submit it, and then just recently Chris Box contacted us and wanted to contribute to the developments. So we have 4 authors now. And what this is, actually I did a presentation of this at Int Area 2 IETFs ago in 122. A link to the slides there. I'll cover just the 3 first bullets of what the contents of that presentation were, just to explain what this is about. So certain layer 2 link technologies have characteristics that can result in packet reordering. There are 2 main causes for this. One is link aggregation. You've got multiple links that have different characteristics, and so the order the packets get striped across those links, the order is different when they come out the other end. And so the receiving end can receive the packets out of order. Second main reason this happens is in layer 2 retransmissions. You've got a sequence of packets that are sometimes aggregated across bursts on a wireless link, for example, and then some fraction of those get lost because of a noise burst, and they have to be retransmitted by the sender. So most of the layer 2 standards that have these sort of characteristics, actually all the ones I'm aware of, have requirements on resequencing at the receiver. So effectively delay all the packets or hold on to all the packets that did arrive or arrived early and wait for the late arriving packets or the retransmissions to be sent in order to forward things out. Is that what higher layer protocols really want? And some evidence that it is not what we want. There is some existing IETF guidance on this from ROC 3819. Basically says, and this is guidance in the ROC is guidance in general for lower layer network technologies. And so it says, well, the internet doesn't guarantee packets will arrive in the same order that they're originally transmitted, and transport protocols must take this into account. And in terms of the responsibilities of the layer 2 links, they should try to avoid packet reordering whenever possible, but not if doing so compromises efficiency, impairs reliability, or increases average packet delay. But then it has a couple of caveats that sound pretty scary. The first one is, if you don't deliver packets in order, TCP is going to have terrible performance. That's sort of important. And then the second one, it says every header compression scheme currently standardized effectively would break if packets arrive out of order. Those two caveats are kind of historic at this point, but they essentially have led to layer 2 networks enforcing this reordering and causing delay and and cost to equipment. So the goals of the draft are to provide up-to-date information so that layer 2 networking technologies and STOs that develop them can make better decisions going forward about the need for resequencing and the effect that would have on IP protocols. So that's that. And then a quick recap on the other 4 slides, just in one slide. The gist of it is latency is becoming increasingly important, hence all the discussion about L4S. Guaranteeing in-order delivery in these layer 2 links increases latency, adds cost and complexity, and provides no value in many cases. Certainly there are some cases where we need to be worried about and understand what the impact is, but a lot of modern protocols are pretty capable of handling out-of-order arrivals. And on the cost and complexity side, so in DOCSIS, for example, we have requirements. We have what we call channel bonding, which is a link aggregation mechanism. We have lots of requirements on sequencing of packets at the sender side and then resequencing at the receiver. And it's a lot more complicated than you might think. I mean, it's conceptually very simple, but things like how do you deal with loss on the links? How do you reacquire sequence numbers if you've lost them? It ends up, there are about 70 pages of spec text that talk about resequencing in one way or another. So it's a fair amount of complexity to do it right and do it well. All right, so goal is to fix this and at least remove or update the text around TCP and header compression. But can we go beyond that? Can we come up with something better? Better than just saying, don't send things out of order unless, don't go out of your way to resequence things. So a couple of suggestions of what we might say that's better. Yeah, that's probably it for this discussion.
Okay, time is up, but the chairs are open to having a discussion. If people would like to comment about this, we can spend some amount of time on it. And if people want to just go to Interia and comment, that's fine as well. So queue is open. Gory.
Gory, this time strictly ask Gory, no one else. With no hat on then. So The reason we did this in 3819, although it was not mentioned, was because of the reordering window in IPsec. And people feared that at the time. I guess 64 packet reordering is now more common than it was then. But I mean, have you spoke to the IPsec people?
I have not spoken to the IPsec people. I'm aware that I've been told that some IPsec implementations are more sensitive to out-of-order arrival than others, and have a smaller reordering window or allowed window. But yeah, that's the expertise I think we need to understand. At what point does it start to cause problems? Are these mainly older implementations, or is this a functionality that needs to carry forward into the future? Yeah.
So the reordering anti-replay window is usually configurable. Some people use 1,000, some people use much smaller numbers. So that's probably worth actually touching base with them and finding out. I also wonder whether where this would be homed best.
Sorry, say it one
Where
more time?
this work would be best homed. I mean, I think you definitely need to go and talk to int area, and you probably also need to talk to sec people. But the people who feel the pain would be transport people, I guess, which is why the PILT stuff came from transport. So homing it might be hard, but I like the idea of working on this subject. So I was trying to be supportive.
Okay. Yeah, certainly would be open to suggestions from chairs or ADs or others on where's the right home for this.
Michael Wessel. I think some of the advice in the document needs double checking on whether it's worth the effort. In Wi-Fi, we have done an experiment where we have seen delays above 100 millisecond occasionally, and the delay in the reordering buffer was below 0.1 millisecond. So that is, according to that experiment, it's a waste of time to even bother. And that may be the case for some of the other technologies as well. So it's probably worth looking into this before suggesting to complicate matters here.
Yeah. Well, there's two reasons to bother with this. I mean, one is to improve performance by not unnecessarily delaying packets. But the other one is to simplify implementations. And so even if the performance gains are small, if standards can be simplified and equipment can be simplified, there's a value there too.
I would argue that any application's benefit of having, or even TCP or whatever, what have you, the benefit of reordering, of avoiding reordering is probably worth it when we're talking about a delay difference of 0.1 millisecond. So
right.
There are lower limits where this becomes absolutely not worthwhile.
Yeah. Other network technologies, the gains can be significantly more than that as well.
Yeah. So that's what I'm saying. It's probably worth digging into this a little bit.
Yeah. Okay. Thanks.
Renzo Colletti, just anecdotes really. We were looking at the IPsec problem, and yes, on Linux by default you get a 32 packet window. You have to turn on this sort of bitmap, and then the bitmap, we can put 4K there, and so it doesn't matter. But if you don't turn it on, then it's very painful. One unfortunate thing that we may encounter is that some mobile carriers have requirements. So 3GPP has these the packet reordering buffers, and mobile carriers are supposed to be able to configure them. And so implementations of modems have these ways for carriers to configure these fields, and that changing those configurations is very difficult. So we I think on Pixel, we tried and failed to remove the reordering because there was too much fear that it would violate some carrier requirements. So that could be a problem for, we did ask the protocol folks, the quick stack folks, the WebRTC folks, do you want reordering? They said, no, we don't. We would prefer not to have it. Sorry, do you want the modem to order the packets for you? And they all said, no, we don't want ordering. Please give us what you have when you have it. But in the end, we weren't able to turn that off. So.
Well, but yeah, I think so. One of the co-authors is on the network equipment side in 3GPP equipment or 5G equipment, and another one is on the network operator side. So hopefully there is interest. Yeah.
Martin Duke, as an individual, 2 points. One, like 3819 was originally done in the transport area, work group called PILC. So I'm not going to insist that it be done here, but it seems like this would be a natural fit. The other thing is, conversely, I encourage you to take as big of a roadshow as you can on this. Not just inter-area, but like IEEE and 3GPP and everyone else that reorder stuff in the network, because this is, I think the advice is outdated, and we should try to get the word out.
Yeah. Thanks.
Yeah, I mean, pretty much what Martin Duke was saying. And in particular, in the case of Wi-Fi, the reordering and the retransmission at layer 2 in Wi-Fi are a huge pain if you do any kind of real-time transport. And so if we could get rid of that, it would be a huge benefit for everybody. Huge. I mean, we're speaking of delay that reach sometimes 250 milliseconds. And that means that you cannot have any kind of real time after that.
Yeah. Yep, agreed. Thank you.
Chris?
Hi, yes. So I joined the queue when it was mentioned of the experience of 0.1 milliseconds of reordering, but like Christian was talking about 250 milliseconds of Wi-Fi reordering. In the mobile network, I've also seen over 200 milliseconds of delay added to the communication flows due to reordering, and there is a timer that lets you configure how long the system should wait for the late packets before it just gives up and sends the one it's got to the application. So that is tunable, but the delays are significant.
Okay, thank you.
Yeah. Michael Tuxen, you mentioned that TCP is allergic against reordering. This is mainly the loss detection, and if you use RAC as a loss detection, that can deal with reordering. So it's a question of older TCP stacks. Yes, that applies. More modern TCP stacks can deal with this.
Yeah, exactly. Yeah. Yeah, and one comment that was made on the mailing list discussion some time ago on this was many of those older TCP implementations may not be super performant on modern networks anyway. And so considering trying to optimize a network for them versus trying to optimize them for modern implementations, yeah, that trade-off. So, yeah. Next up. Yeah, Michael again.
Okay, Michael Wetzel again, reiterating my point. The point of the reordering buffer on the receiver side of Wi-Fi, so this is answering back to Christian, is to be able to get the data when Wi-Fi is retrying with putting data in aggregates, which it only does a couple of times on the basis of the round trip time, the physical round trip time of Wi-Fi, which is basically nothing. Whereas one can get really large delays on the sender side as the sender is trying to get data on the wire and it's waiting for RTS, CTS to finish. So as I said before, we have an experiment which is unpublished, but we have data similar to what Christian has seen with delays above 100 milliseconds. Yet the receiver side reordering delay was below a tenth of 1 millisecond. So I disagree that this is a huge problem in Wi-Fi. I don't think that this is where the delay in Wi-Fi comes from. At least, if you want to change it, if you want to fix that, I think you should be the one bringing evidence that this is useful. And I think at least one. I have one sample that shows the opposite.
Yeah, there was a contribution to 802.11, I think it was last year, that provided some data on the extent of the issue and what benefits you get from disabling resequencing. So that might be a good reference for us to compare to your results. Yeah.
Yeah.
All right, is that it?
All right. Yeah, the queue's closed. Thank you, Greg.
Thank you.
Next up is Mohit, who's remote.
Hi, can you hear me?
Yep. I'm trying to give you this slide control. Just give me a minute. Where's... Oh, thank you.
Yeah. I think I have the slide control. Yeah. All right. Hello, everyone. I'm Mohit from NITK. I'll be giving a quick update on the internet draft on FlowQPy. For those who have not been able to read the document or have not attended the previous presentations, just a quick overview of this draft. Basically, it combines FQ, which is flow queuing, with the Pi algorithm, pretty much similar to how FQ-Codal combines FQ and Codal. And the functionality of FQ is pretty similar to what we have in FQ-Codal RFC 8290. And the functioning of Pi is pretty similar to what we have in RFC 8033, but with one minor modification on which we also have an update, which is about using timestamps to use Q delay to calculate Q delay instead of using little slaw. And we have about 3 implementations of FQPy. We have some Linux distributions supporting it. We have it in FreeBSD and also in the NS3 network simulator. The history of this document, of course, 00 was the basic algorithm, with 01 adding the scope of experimentation, particularly borrowing scenarios from RFC 7928. The 02 draft added text about the FreeBSD implementation of FQPy. And there was also an adoption call that ran for about 3 weeks. Thanks to TSVWG for taking that. In the last presentation at IETF 123, I received a suggestion from Greg. Greg mentioned that it would be interesting to study what impact it has on the performance of FQPy when you use timestamps, because we are deviating a little bit from RFC 8033 recommendations. So RFC 8033 recommends using little slaw, also provides timestamps as an optional feature, but we recommended in our internet draft that timestamps are better to use considering the fact that you have multiple queues. So we received this feedback from Greg, and we ran a few experiments. We ran experiments with simultaneous TCP flows starting at the same time. We had TCP flows starting at different times, so staggered start. We also had TCP flows with different RTTs. We also ran experiments with pulse wave, where we oscillated the bandwidth every 5 to 10 seconds. And we also ran experiments with UDP background. And we did not see actually a lot of difference between both the schemes, particularly little slaw and timestamping. We ran these experiments to confirm that timestamping is not impacting the Q delay estimation in any way. And we are still running some experiments. In fact, some of my students were at the hackathon, and they have also been trying to run the experiments on the live network, but we are still yet to interpret those results. But yes, this is an update. Thanks for the suggestion, Greg. It helped us run these experiments. That's it for this presentation from my side.
Go ahead, Greg.
Hi, Mohit. Greg White, Cable Labs. Thank you for taking that suggestion on board. The history of why I asked the question is when the AQM working group was around in IETF and was discussing CODL and Pi and different AQMs at the time, one comparison that was made was The caudal algorithm was using timestamps, using the Saussure time calculation, which and it was making the packet drop decisions at DQ time, like so right at the head of the queue. When you've got a bit availability of the link to transmit, you can decide to drop packets there. Versus Pi, the implementation was based on Little's law predicting the queuing delay, but the packet drop decision was made at NQ time. And initially there was some discussion about, well, is there an advantage to doing the decision at DQ time because you get your congestion signal to the receiver more quickly? It's not waiting in a queue. But then between the two algorithms, Caudal was using kind of a delayed estimate or delayed sense of the queuing delay because it's a measurement after the queuing delay has happened, versus Pi was predicting what the queuing delay would be. So the suggestion, or I think the conclusion was, it would be essentially a wash. But in the implementation that you had been working on here, you were sort of giving up that early I believe you're giving up kind of that early estimate of queuing delay in Pi and just using the Saussure time. So you were, potentially having that issue of delayed feedback to the receiver, and then obviously delayed response. So it's interesting to see that there wasn't much observable difference between the two. So yeah, thank you.
Yeah, sure. Thanks, Greg.
So it's kind of my attention that I started a call for adoption on this document back in Madrid and never closed it. It is about to close. So does anyone have any reason not to adopt this draft? Please say so now, because I'm going to send out the email very shortly that it's approved. Okay, Mohit, you're free to submit draft IETF FQPI at your leisure. I'll send out the approve. I'll push the button in Data Tracker as soon as I can to formally adopt it. Thanks, everyone.
Thanks,
Last up.
Thanks, Ed. Yeah.
You also need to add a milestone on that. You also need to add a milestone. New milestone.
Well, somebody needs that. Okay, so next up is Magnus to talk about DTLS and SCDP. And this is our last talk of the day.
Did you click your work order?
Yes, I'm working on it.
Good.
There we go.
So I get 4 minutes? No.
You have lots of minutes.
Yes. So my name is Magnus Westlund. I will speak here for my co-authors, Michael Tuxen, Jon Mattsson, and Claudio Porfieri. So what we talk about there is a bit about the update, the liaison statement, and then we have 5 issues we want to see if we have get any feedback on. So the 00 working draft was identical to the individual 05. The first working draft with changes was doing some fixes. We were addressing an issue with sequence number protection key also needed provided. So this is that DTLS 1.3 needs not only main encryption keys, a key to create the actual salt to create the IV from the taking the IV plus the salt to create the nonce for the AAD algorithm. You also need a key to do sequence number protection. So, and we fixed a bit around the API discussions and the much more complete socket API. So the liaison statement. Yes, this was supposed to be sent much earlier. I'm the one to blame. I took it on me and I forgot to write it until I realized this and got to work on it. So I sent out the draft LS text earlier today on the mailing list. This has been going around among the authors, etc., and we're fairly happy with it. And based on the 3DPP's meeting, we would like to get this sent before the end of the week. So it's basically if anyone has looked at the text to have any feedback, it would be good to get that in. Otherwise, I hope the work group chairs can they have the right to make a decision on the LS and send it before the end of the week. So
Yeah, I think the idea would be like you have the LS on the mailing list, have a look at it. If you have any comments, any suggestion, that's most welcome. But I think it should be, we would like to send it at the end of this week. So in the next 2 days, basically, if you can provide something. Otherwise, I personally think this is in a good shape. Maybe some tweaking on the timeline that was written there.
I could show you what I think it's
the next one.
It has not been sent out on the list.
What?
No,
it was sent to
should be.
chairs.
No, it was. I'm gonna send it today, Maureen.
I think it was sent to list today. So
yeah, should be.
Ah, yes, there it is. Different email.
So here is it like they?
Yeah, it's the later part of the first paragraph here. I think you're. Yeah, that we cut it down a bit to just say that we're working on this. So, but yeah. Anyway, so here is the text. If you have any comments, please provide them. Otherwise, I hope we'll see it going out. Yeah. So let's get into the issues. Yeah. So the first one is around negotiation of the DTLS chunk and its clarification how to do it. This is the clarifications we want to do here is so saying is to understand how you do this initial process when you're doing the STP association initiation, creating the association. And we have the DTLS 1.3 chunk protected association parameter. And that includes a list, prioritized list of solutions, what we call protection solution identifiers, which is basically saying which key management methods are you willing to use with the chunk. And the initiator, basically wants to start trying to create an association, will send a full list of supported methods in priority order it supports. The responder, so saying normally the server or whatever you see it, will send a parameter back with only the choice it selects. And because this is plain text, the downgrade protection to prevent any man in the middle to change this is that each side will take what it actually sent plus what it got and input that in the combination of offer list plus selected answer into the key derivation. So if anyone manipulated this in the middle, they will create an failure in the key, in the key derivation. Basically, each side will have a key, but it will not be the same key, and therefore the communication will fail at that point. So, preventing the a downgrade here. So, so that's mostly clarifications. I don't know if anyone has any feedback on this before we go on. Yeah. Probably not. Yeah, you can jump up and so. This is much more of an open question, which comes to the alignment of the DTLS record. So the first 32 bits of the chunk is the chunk header. So type 1 byte of flags and 2 bytes of chunk length. After that, it's up to the chunk to define what's contained. And the issue here is about the DTLS record has basically first byte with flags. Then it can be 1 byte or 2 byte of sequence numbers. There's also possibility to have the connection ID, which is a number of bytes. I think it's 2 also. or more. And that makes and then you will have encrypted parts of the details record. And if you want to do decryption or an encryption in place, you want to align this. You might have an implementation require 32-bit alignment like FreeBSD to have this requirement. So it would be good to be able to align the beginning of the place where you will have encrypted information to a 32-bit boundary. And to ensure that you can do this, we would need to have 0 to 3 bytes of padding prior to the details record. So the proposal here is to basically take 2 of the chunk bits, use them as an indicator of how much padding you have. So how many of these purple padding bytes you have before the record starts. So any comments on this? Yeah, I mean, we plan to implement this if we don't get any kind of comments on being a bad idea. So then we have AES-conf and details chunk. So this is where you can announce new interfaces or send packets from a new interface to an existing STP association. It's defined in 5061. And to be able to do this securely, that required STP auth to authenticate the AES-conf packet. The AES-conf includes an address parameter, and that's a known address for the association. And it's used to look up which association this packet comes in when it comes in from an unknown source address. The problem here for details chunk is that details chunk will encrypt all of the other chunks. So you will have no information in clear text telling you which context does this packet come from if it comes from an unknown address. So for that reason, if you want to do if your current interface fails, you have some new interface to send from and try to send for that. If you have ASCONF configured, will not work under details chunk. However, what you can do would be to send it over an existing path, which is well known, because then you will have the identified association correctly, and that can announce the address information for the new interface. So you can do make before you break. So our proposal here is to basically accept the limitation on AES-conf to just be an announcement method for new interfaces, and also do an update to 5061 that if you're saying that if you have a session association negotiated details chunk, you will use that instead of STP auth as the way of proving the authenticity of this packet, and basically do that basic update. So, and accept this limitation. I think that's the easiest way forward. So, any feedback on that? Michael
Türksen, maybe one additional information. So it seems like the AES-conf feature is not needed by 3GPP.
Yeah.
So in the area for which we are developing this, they don't need this extension.
Yeah. We had another issue on details record limits. So this is if there exists an RFC 8449 that for TLS to negotiate smaller maximum record size to be used that is smaller than the 16,384 bytes, which is the normal max size. This extension has been mostly kind of be presented as a way of limiting implementations, resource consumption when for large records, for example, in IoT devices. It's not very well implemented to our understanding, and we don't consider, at least for the main use cases we've been discussing, the using detail as chunk, etc. for. It's not primarily, it will not be resource constrained devices. So handling a 16K records are not a problem. And to remind you here, the actual record sizes going to be used is actually based on the packet sizes. So the primary case where you would see 16K records would be over loopback interfaces and things like that actually have an MTU that is that large. Otherwise, you will primarily use record sizes. It will be basically limited by MTU most of the cases. So the proposal here is to not provide any support for this option, and endpoints will assume to support 16K byte records. Okay, no comment on that. Or
Michael Tüxen, I think in the TLS working group, they are working on a BIS document for DTLS 1.3.
Yeah.
We should double check that this DTLS record limit is not part of
mandated functionality, yes.
Mandated functionality in the updated DTLS 1.3.
Yeah. And then we have the kind of invocation limits and application interactions. So this is more a question of feedback. So the abstract API specifies get methods currently about, okay, how many encryption invocations have you received? How many successful decryption invocations have you done? And how many failed decryption invocations have you done? Normally you want to combine the two last to see, okay, do we think we have a attack, especially failed ones, is the indications of potential attacks, etc. People trying to do forgery test attempts on you as a receiver. So if you get enough, you maybe want to trigger the rekeying or things like that, just to ensure that the attacker doesn't have as easy work as possible to actually attack you. And the encryption invocation is a limit on how much, usually based on the cipher, how much you can do. So the question we have here is like, is it beneficial to make an event-based invocation? For example, notify me when the total encryption invocation has reached the number n. Because that's when maybe you see as a limit for when I should start doing a rekeying so I don't run over the limit. Or notify when the total decryption invocations has reached M or the failed one has reached O. So we might add this, at least for the Michael was considering adding these type of interface to the socket interface using event-based. And we might consider to also make the abstract API saying that either of these is fine. So we are asking about, is there any kind of consideration around the impact of using these type of values with event-based, etc. And so.
Hi, Tüxen. It's also the question whether it's that simple. So if this number goes above that threshold, it's critical, or whether there are more complex conditions, like if this combination of these values go above this, then it's critical. So it's about a question whether the application should poll periodically or gets notified.
Okay, seem to not get any feedback today, but I hope we can, if you have any input, please provide it. So the plan going forward here is to incorporate the proposals from this into the draft. there are also some more editorial fixing around the kind of introduction and limitations of the draft, etc. This text we can cut down to get the cleaner, more focused description of the draft. And we do target a draft version before the end of the year, so to maintain momentum here on this draft. So any other comments, questions around the draft? Okay. Done.
All right, lovely. Thank you, Magnus. That concludes the session. See you all in Shenzhen.
Yes. I had another more question. I forgot one thing.
All right, do you want to get away from the mic? Or?
Yeah.
All right, I think that's a better idea.